All right, today we are in section 2.4, Congruent Figures, page 63 in our books. All right, the first thing we're going to start with are some terms. All right, so make sure you fill in the blanks here. A rigid motion, all right, you're going to hear me say this term quite a few times in this lesson. It is a transformation that keeps the original length and angle measure. So translations, reflections, and rotations are rigid motions because we've talked about the fact that they don't change shape. All right, they might just slide or flip or turn, but they don't change shape. So that's really a lot of what we're doing today is we're going to try to find figures that are the same size and shape and figure out what kind of transformation has happened. So congruent figures have the same size and shape, and they are obtained by one of the rigid motion transformations. What does that mean? It means I did a translation or a reflection or a rotation to get my congruent figures. All right, and then just remember congruent angles and sides have the same measurement, equal in measure. All right, so in example 1, I have a lot of triangles here. All right, and I'm trying to figure out which ones are congruent, which triangles are congruent. Well, one thing that's important when I'm naming these triangles is I need to name them in alphabetical order. All right, so let's first start off by just picking out the triangles here. Okay, so we have a triangle here, P, Q, and R. All right, we've got M, N, and P. We have D, E, F. All right, and then we have the 2 on the right side. So we have 1, 2, 3, 4, 5 triangles in this graph. Well, all 5 of them are not congruent. Okay, so I need to identify which ones are congruent. The way I do that is by looking at how many units wide or basically like length and width on these units to figure out, are they congruent? Once I establish that yes, they are congruent, I need to figure out what kind of transformation, or in this lesson we call it a rigid motion transformation, has happened. All right, so let's point out the first one. We see that DEF is 2 units high and 2 units wide. You see that's 2 blocks. What other triangle on this graph has the same dimensions? Okay, yes, it's going to be M, N, P. All right, same exact dimensions. So now my question is, yes, I've identified, okay, so I come over here and I would say triangle, okay, so that's my little symbol. Triangle DEF, we say it in alphabetical order, is congruent. So that's an equal sign with a squiggly line on top to triangle MNP. But why? Okay, so now I have to identify what kind of transformation has happened here. And guys, there's not just one specific answer. Okay, so most of the time, I don't want to say most of the time, a lot of times we can just say that it was some kind of a translation. A translation, remember, slides the figure. So you're going to identify 2 corresponding, so there's a word corresponding, it means in the same location on both triangles. So you see how both of these points are the top point of the triangle. All right, in order for it to be rigid motion, which it is, all the points are going to move the same direction, so I only need to compare 2 of them. So let's count how many units it moved. It's a translation, and I went 1, 2, 3, 4, 5 units up and 1 unit right. So I come over here and I say translation, and we can make this real brief. Translation, 5 up and 1 right. okay? And now we not only have said which figures are congruent, we've also said what transformation or a rigid motion transformation has happened here. Rigid means basically that it's not changing size and shape. All right, do you see any other triangles that might be congruent? All right, so if you picked out J, K, and L, and A, B, and C, you are correct, because I can see that my base is 2 units and my height is 3 units, and the same is true with J, K, and L. All right, so I come over here and I say triangle J, K, L is congruent with triangle ABC. But now the question is why? What kind of transformation happened here? All right, well, it's not a translation because it's facing in a different direction. So it can't be a translation. So I have 2 other types of transformations to choose from. What do you think? Try to write down your answer. Okay, so if you said a reflection, you are correct, but you have to be more specific. Which axis was reflected to get from one to the other? I reflected over the x-axis. So that's, all right, reflection across x-axis. All right, so you have to say which axis was reflected. And that's it for example 1. This is a really important example in the lesson. All right, in example 2, now I'm told that the red figure is congruent to the blue figure. Okay, so that's important. Because it's congruent, I know that a sequence of rigid motions has gotten me from the red figure location to the blue figure location. So now I need you to tell me what transformation has happened to get from the red to the blue. Now, sequencing means that more than one thing is possibly happening, and that is true. It's not just one transformation that gets me to this point, because first I have to turn the figure so that it's facing the same direction as the blue figure. So how could you turn the figure? And when I say how, I mean what degree of rotation would turn the red figure to the blue figure? What degree of rotation? Okay, if you're thinking it would be counterclockwise because I need to rotate it upwards, you are correct. It's counterclockwise. And in 2.3, we talked about every, we'll call it a click or a turn, is 90 degrees. And it only requires one turn to make it face in the same direction as the blue figure. So this is going to be a 90 degrees counterclockwise, we'll abbreviate CCW for counterclockwise, rotation. But when I do that, it's still not in the final location. Okay, so let's identify where at least 1 or 2 of the other points would be. Okay, let's just start with this point right here. It's at 0, 0. That's really easy, right? Because even a rotation 90 degrees counterclockwise, well, what's going to happen if I flip them and I do the opposite value? It's still going to be 0, 0, right? So now the red figure is rotated, but this point is still fixed here. So now all I have to do is match it with its identical point on the other figure, and I can see that it was a translation 1, 2, 3, 4 units up. So you see, once you identify the first transformation, you then pick a point on the figure. You may have to do a little bit of math there, and we'll work on that a little bit more together when I return on Friday. But the way we figure out the final location is to pinpoint two of corresponding points, just like we just talked about, and then we can see it is also a translation 4 units up. Okay, and you could just say 4 up. All right, okay, so that's it for example 2. In example 3, we just see some images over here on the left, and they're basically just showing us how different buttons on a computer program can move or can transform. So it's basically, honestly, I don't really know what the point of those buttons is, but let's look at the smiley faces because that's what it's asking us. It's saying that you can rotate the objects 90 degrees in either direction and then reflect them, okay? So how can you transform the emoji as shown? So again, how could I get from original to the image? Which way would I turn the original figure? If I turn the original figure, if I need to turn it down, then I would say it's a clockwise rotation. If I need to turn it the other way, I would say it's a counterclockwise. So what do you think? Okay, so if you said 90 degrees counterclockwise, you are correct. It is a 90 degrees because then that turns it on its side, okay? But now what problem would we have? We made a 90-degree counterclockwise turn, but there's still something about the original image or the original figure that's not the same as the image. Do you see what that might be? Okay, you see how the tongue over here is on the left side of the mouth, but over here it's on the right side of the mouth. So what I can understand is I can actually reflect. I can cut this image. Let's see if I can make a better line. I can cut this image in half, and then once it's turned, I can reflect it across, and what kind of line is this? It's a horizontal line, right? So a reflection on a horizontal line would get me to that end image. All right, so there's a couple things that I want you to take away from your lesson today. One is we're now looking at the starting and the finished congruent image. Basically, they've been transformed somehow. All right, so we've learned these transformations, and now I'm looking at images that are congruent on the graph, and I have to figure out what transformation has happened between the figures. All right, that really is the main point of this lesson. And if you understand that, that really is the main part of what you need to know for the lesson. Okay, so that gets us into our classwork. Okay, this will be a graded assignment. There are 3 questions here, numbers 3, 4, and 5. So what I want you to do individually on your own is I want you to use that coordinate plane on number 3. You have 3 figures drawn on the coordinate plane. Tell me which ones are congruent. Remember, when you're labeling them, you need to label them in alphabetical order. Remember to use your congruent symbol. Okay, so that's the equal sign. So whatever one figure is and the other figure, show that they're congruent that way. That's what I'm going to be checking for. Then I want you to look at B. It says a rectangle has vertices and it gives us 4 points. Is this rectangle congruent to any of them? You can plot that. Okay, it might overlap with one, it might not, I'm not sure. It looks like it might overlap, that's okay. I want you to plot those points on the coordinate plane and tell me if it's congruent with any of them, okay? If it is congruent with another figure, I want you to tell me what kind of transformation happened between the 2 of them. Did it slide from one figure to another? Is it a translation? Did it reflect? Or did it rotate? All right, look at numbers 4 and 5. Something has happened between these 2 figures to get from the blue one to the red one. It's either a translation, a reflection, or a rotation, or it could be more than one. So here's what you need to do. Pick a point, and then pick the same point on the other graph. And as long as you fix the same point, you can figure out what kind of transformation has happened. On number 5, I'm just going to tell you right now, it's more than one transformation. Okay, you can't just translate it and get to the red figure. All right, so again, how many clicks or how many turns have to happen, and then how is it going to slide? Okay, so you might need to actually rotate these points. Okay, and do that right there on your notes. You can go ahead and rotate it, and then you can figure out how it moves from there. Okay, so do your best on this assignment. I want you to take the rest of class to work on it, maybe 5 to 10 minutes, depending on what time it is, to work on it on your own, and then pair up together, and you need to work on this assignment. This will take the place of your homework assignment tonight. Okay, so if you don't finish these 3 questions, you will need to finish them by Friday, but you do not have to do the 2.4 assignment that's on the board. Okay, this will take the place of it. All right, that's everything for today's lesson.